When we were looking at scatter plots and these trends, we were trying to say whether a correlation seemed to be strong or weak. And it was somewhat of our opinion, and we could say things like, well, I think this is kind of weak or somewhat strong or very strong. And that poses a little bit of problems. It really can, because what we really need is we need a number that we can associate and attribute to that to tell us exactly how strong or exactly how weak this correlation is. And that leads us to what's called the correlation coefficient. That is a number that measures the strength of a linear association between two numerical variables. It's represented by the lowercase r. It's always a number between -1 and +1. If the r value is negative, then your trend is negative. And if the r value is positive, then your trend is positive. If your r value is close to either -1 or +1, then your trend is very strong. However, if the value is close to 0, then your trend is very weak. And an r value of exactly 0 means there is no correlation between these two variables at all. An important note to make at this point, though, is that correlation does not mean causation. We are looking for relationships between two variables in question, but identifying an association does not mean that X causes Y. Cause and effect cannot be determined by an observational study. Only correlation or association, no matter how strong the correlation is. And this is very, very tempting. We can find a very, very strong correlation between two variables, and it can be very tempting to say, well, that means that one causes the other one to happen. It's so strong, it has to be that way. And that is simply not the case. Recall that a controlled experiment is needed in order to prove any sort of a cause and effect relationship. And in the absence of a controlled experiment, regardless of how strong the association is that you may find, you cannot declare that one variable causes the other one to happen. Let's go ahead and open back up, or keep open possibly, that flight times data set that you should have, the flight times from Boston. Before we actually calculate, do you think that the r value will come out positive or negative, and why? Well, based on above, we say that an r value basically tells us the trend. If it's a negative r value, it's a negative trend, and if it's a positive r value, then it's a positive trend. So we've already looked at this image. It is a positive trend, so I think my r value should come out positive. We saw a positive trend. So I expect my r value will also come back positive. Will it be close to 1 or -1, or will it be close to 0? So again, remember what we just were defined is that close to 1 or -1 means a very strong trend, and close to 0 means weak. We already decided this was very strong, and we just said positive, so I think this is going to come back very close to a +1, because from above we saw it's positive, so -1 wouldn't make any sense. And additionally, we see visually a strong trend, right? Very little scatter. So if I have the image first, then I can sort of think about what my R value should come back like. And if I get my R value first, it should give me an idea of what my image should look like back and forth. So now we want to actually calculate this R value using Excel and compare to these answers above. Okay, so let's find that R value. Let me minimize this. To find an R value, you need your data in Excel, which we already have. So select any open cell and use the command equals correl for correlation. Put your explanatory variable range in, comma, response variable range in, enter. Okay, so I'm going to choose this. I'm going to say, actually I'm going to write R value, okay. So in my next one, I'm going to type in equals, and correlation comes up as an option. I need my explanatory range first, so all my explanatory variables, comma, I need my response variables, close it up, and hit enter, and I get a R value, or a correlation coefficient value, of 0.9947. I'll keep 4 decimal places is fairly standard for that. So I'm going to say that R equals 0.9947. And does that compare to my answers above? I'm going to say yes, because it's positive and very close to 1. Okay, so I got what I basically expected. It says, as an experiment, make a new scatter plot reversing input and output and do the graphs look the same or different. So we want to do a little bit of an experiment. Let's reverse the input and the output. So make a new scatter plot. Let's see, if I want to, I need to reverse these. So I'm going to copy, oops, go back. I'm going to do a copy and paste. Oh goodness, it's not working. Of course it's not working. There we go. So reverse these, do time and then distance. And of course my garbage is being picked up right now, so I apologize for that. Okay, so I'm going to highlight those and do an insert scatter plot and look at visually this scatter plot versus the other one. They don't look exactly the same. They still both look positive and very strong, but I can see the differences. Like the points are not in exactly the same spot, right? The points have reversed their X and Y values. So now these 2 points, instead of being almost horizontal, are actually almost vertically now. And the points are not themselves in the exact same spots. So what I would say, it says, do they look the same or different? I'm going to say that they look different. The points are in different spots now, in different places. Still looks strong and positive though. Okay, so it looks different. And then it says recalculate the R value with the input and output reversed. What do you notice? So if I recalculate this R value and do a new R value, and come down here and do a new R value and do equals correlation. This time these are my input, comma, output. Notice that the R value I get is exactly the same though. So that's an interesting point because that basically matches with what we said here. The R value is the same. Okay, it didn't change. The R value is simply a measure of your strength and your association. So the strength we said was strong and the association was positive. So those two things don't change. The strength and the association does not have a direction to it as far as input and output goes. So even though the points themselves move around. The equation that you get between the x and the y variables, if you switch x and y, you're going to get a new equation, but how strongly those two variables are related to each other and in what direction they are related to each other doesn't change if you reverse the input and the output. So that's a very interesting feature about this R value.